Okay, I'm back, and now we want to do vertical motion equations. So in our previous lab, we did the moving man who was walking sideways across the screen, and so that was horizontal motion. And we found out that there were three equations that could describe horizontal motion. And so the first one was the how fast equation. And so what we said back then was that it was going to be his final velocity was going to be equal to his initial velocity and then plus his acceleration A and then times t. So that was the equation for horizontal motion. Now, what we need to do is put more subscripts on this, because when we were graphing, we said that y was up and down and then x was sideways. So what we're going to do is put a x here. So this is his velocity in the x direction, and it's his final velocity. And then we could do the same thing here, and we're going to put an x there for his initial velocity in the x direction. And then this is a sub x. What about this one? Should I put t sub x on there? Well, not really. So time is time. And so it's a scalar, so it doesn't really have direction, so we don't need to put an x on that one there. So to make this equation work when we're going up and down, one thing that we're going to do is we're going to have the velocity in the y direction instead of the x direction, but it's still going to be the final velocity. And then over here, this one's going to be the velocity in the y direction, and it's going to be the initial velocity. And then we're going to need to add the acceleration, but it's going to be the acceleration caused by gravity. So if you take anything and you let it go, it's going to fall down because it's being pulled by the force of gravity. Later, we're going to find out that there's an equation that's going to relate force to acceleration. And so the force of gravity is going to cause the acceleration due to gravity. And it has its own special letter. So G for gravity. And then we still have the T. Okay? Do we need to put G sub Y on there? No, because gravity always pulls down. So we can just leave that as a regular G, leave this as a regular T, and so this is going to be the how fast equation for vertical motion. And then G is going to be equal to, now the magnitude of G is 9.8 if you want to go to two significant figures. If you want to go to three significant figures, it's going to be 9.81. And then the units, it's an acceleration. So it's going to be meters per second squared. And then gravity pulls down, so we could put a negative sign on there to indicate that gravity goes down. But sometimes you don't see it that way, and the acceleration due to gravity, they take the absolute value of it, and so it's positive 9.8. But when you go to plug it into your formulas, it's got to have the negative sign on there, because signs are important. Things that go down are negative, and then things that go up are going to be positive. Okay, so finally we got this equation right here. Okay, now let's think about what was the ball doing just before you hit the play button. what was the speed of the ball just before you let it go? Okay, it was 0. So that means that we can erase this part right here because it had 0 initial speed. And then for that matter, we can get rid of this thing right here. And so our final answer is V equals GT. And now you might be saying to yourself, no, I just made a mistake because this should be a negative G right there. And then if this is a positive number over here, we're running into problems because then we would end up with a negative time, and then we've just invented a time machine. So that's no good. But remember, what were the velocities? The velocities were what? They were negative 2. So what happens when you got a negative and a negative? They cancel. So therefore, we could write this one down as just being V equals GT. So that's our vertical equation of motion. Now it's your turn. So here is the how far equation. So this one is the how far going sideways. So you see I've got R sub X, and then this would be then the velocity in the X direction, and then this is the acceleration in the X direction, and then T squared. I would like for you to take this equation and then rewrite it so that it would go for R in the Y direction, the up and down direction, so that you will have an equation that is going to say the distance that it falls in the Y direction is going to be equal to, and then you put in the rest of it. So do it exactly the way that we just did it for the how fast equation, and then you write that answer right here. Then you got the hybrid equation. So the, whoops, I don't want to show you that yet. You probably have already looked at it. Shame on you for doing that. So let me just erase all of this. I wish I had a larger screen, but I don't. So you should have a equation for the how fast when it's going up and down, and then you should have a equation for the how far, and then we got the hybrid. So the hybrid was the one that said the velocity, and now if we were going sideways, it would be X and then final squared. Make sure and square it, and then that's going to be equal to the X initial squared, and then plus 2. So it's important to put that 2 in there. That 2 is in there for the same reason that this thing up here has a 1/2. And then it's going to be A, and that A would be in the X direction, and then the distance that it travels in the X direction. So that's the hybrid equation. And again, I'd like for you to take this equation and then rewrite it so that it's the hybrid equation going up and down. So do that. Did you do it? You better. So don't just wait for me to do stuff for you. So you do it on a scratch piece of paper and come up with the hybrid equation for vertical motion. Okay, ready? Okay, so this is what you should have obtained. Okay, so we've got over here, these are the horizontal equations of motion, and then over here is the vertical ones. And you should notice that the vertical ones are much easier than what the horizontal ones are, because it had no initial speed. Now sometimes it's going to have a initial speed. So it's just in this particular case, you had the ball in your hand and then you dropped it. So for other questions, you might have the ball on the ground and you're throwing it up into the air. So if you throw it up into the air, then you are going to have an initial velocity. And so the equations of motion are going to be a little bit more complicated than this. So this is the equations of vertical motion when you got something in your hand and you're just dropping it. Okay. All right. So now we are actually ready to calculate what the acceleration due to gravity is. And we're going to do that in part 4 in just a moment.